All right, let's talk about one of the most critical steps when you're building with AI, and that is, how do you turn that simple little experiment, that script you've been working on, into a robust, scalable application? If you've ever wondered how to actually get from a proof of concept to a real production-ready service, well, you're in exactly the right place.
So, if you're working with large language models, I'm going to bet you started on the left side of this screen, right? With a quick script, and hey, that's totally fine for a test. But let's be honest, it's fragile, its usage is completely untracked, and it's basically a one-off. If you want to build something serious, something real, you've got to move to the right and create an LLM service. We're talking something that's reusable, governed, and actually built to last.
And this, right here, this is the crucial point. It's a fundamental shift in how you think about this stuff. You're not just calling a model anymore, you are building a back-end product. And that one simple change, it affects literally everything, from how you develop it, to how you secure it, to how you run it. You know, what's so cool is what this little change unlocks. I mean, think about it. By wrapping your LLM calls in a service, you instantly make them reusable for any app you build. You can swap out providers, maybe go from OpenAI to a self-hosted model without having to rewrite everything. And maybe most importantly, you create one central place for governance. You can control access, log all the usage, manage those costs. This is the foundation for running these systems like a pro. Okay, so how do we actually build this thing? What does the core blueprint for an LLM API even look like? Let's get right into it, because it's probably more straightforward than you think.
At its heart, the architecture is actually pretty simple. You've got a client, that could be your web app, a mobile app, whatever. It makes a request, but not directly to the LLM. It makes a request to your API service. Your service is the middleman. It handles all the logic and talks securely to the LLM provider, whether that's OpenAI or a model you're hosting yourself. The key is you own that middle layer.
And here's the best part. You don't need some massive, complicated framework to do this. I mean, Python is pretty much the language of AI, right? So simple, modern tools like FastAPI are perfect for this. They let you create a clean, super high-performance API that sits right between your clients and the LLM. It makes the whole thing way more accessible than you might imagine. So your service is going to expose what we call endpoints. A good way to think of these is like specialized doorways into your service. You might have one door for general chat, another one specifically for creating text embeddings, and maybe a third for some other special task. Each one is a clear, versioned entry point for a very specific function.
All right, so we've got our basic API. That's a great start. But now we got to talk about what it takes to make it ready for the real world. This is really where we separate the simple little experiments from the serious enterprise-grade applications.
A production-ready service absolutely lives and dies by what we call its API contracts. The request you send can't just be the prompt. No way. It needs context, like a user ID, so you can do tracking and rate limiting. And the response can't just be the answer. It has to include that critical metadata, like which model was used, how many tokens it burned through, which is key for cost tracking, and a trace ID so you can debug when things go wrong.
But wait a second. The moment you expose this service to the world, a huge question pops up, right? How in the world do you control access and keep this thing secure?
Well, the answer is you need layers, a bunch of them. First, authentication. You got to know who's calling your service. You can use simple API keys or something more robust like JW tokens. Think of those as temporary digital passports. Next, all communication has to be encrypted with HTTPS, no exceptions. Then you absolutely need rate limiting. This stops abuse, but just as importantly, it prevents a single user from accidentally racking up a massive bill. And finally, of course, you've got to validate all your inputs and think about content filtering to keep things safe.
Okay, so security is one side of the production-ready coin. What's the other side? It's observability. I mean, if you can't see what your service is doing, how can you possibly operate it effectively? You can't. This right here is the foundation of what we call LLM ops. So what exactly should you be logging? This table breaks it down perfectly. You need the user ID to track who's using what. You need to know the model and tokens used. That's absolutely critical for analyzing performance and, you guessed it, costs. And then you have things like latency and status, so you can monitor the health of your service and jump on errors the second they happen. Okay, your service is secure, it's observable, fantastic. But what happens when it gets popular? That's a good problem to have, right? Well, now you've got to make sure it can handle all that new traffic without just falling over. So the standard way to scale a service like this is what's called horizontally. It's actually a simple idea. Instead of making one server bigger, you just run multiple identical copies of your API service. Then you stick a load balancer in front of them. Its only job is to take all the incoming requests and spread them out evenly across all your service copies. That way, no single one gets overwhelmed.
Okay, this is where things get really cool. Once you have this microservice architecture in place, it unlocks some seriously powerful and efficient patterns for using these models.
One of my favorites is called model routing. Just think about it for a second. Why would you use a massive, super expensive model for a simple task? You wouldn't. Your service can be smart enough to route requests based on how complex they are. Use a small, fast, and most importantly, cheap model for simple things like tagging, and save that big, powerful, and expensive model for the heavy lifting like complex reasoning. This one trick alone can save you an absolute fortune.
And maybe the most powerful pattern of them all is building a dedicated microservice for RAG, which stands for Retrieval Augmented Generation. This is the magic trick. This is how you let your LLM answer questions using your own private data. We're talking internal documents, a product knowledge base, you name it, all without having to do any expensive retraining of the model itself.
So how's it work? The flow is actually pretty elegant. When a question comes in, your RAG service first searches a special vector database to find the most relevant pieces of your own documents. Then, it takes that juicy, relevant context, sticks it right into the prompt with the user's original question, and sends that whole package to the LLM. What you get back is a contextually aware answer, and you can even show which source documents it used. Super powerful.
Okay, but let's be real. In the real world, things break. Your LLM provider might have an outage or just get super slow all of a sudden. A real production service has to be able to handle that.
This is where you need a plan B, or even a plan C. These are your fallback strategies. You can automatically retry a failed request, maybe after a short delay. You can have your service automatically fall back to a different, maybe smaller and faster model. You can even use something called a circuit breaker, which is just a fancy term for a smart switch that temporarily stops sending requests to a provider that's failing, which protects your own app from a total meltdown.
So when you pull all these pieces together, the API design, the security, the scaling, the resilience, you start to see what this core LLM ops mindset is all about.
You see, a really great LLM service does all of this stuff. It gives its users these clean, simple endpoints while hiding all the crazy complexity of model routing or RAG under the hood. It gives you deep observability with great metrics and logs. It handles all the security and enforces rate limits. And this is key, it's built from day one to support versioning and experimentation so you can keep making it better and better over time.
And that really brings us to the ultimate takeaway, the core principle that separates a weekend project from a professional, reliable AI product. It's this: don't just connect to an LLM, build an LLM service.
So, I'll leave you with one final question to think about for your own projects. Is what you're building a script or is it a service? Because trust me, the answer to that question will define its entire future.